Welcome to Spaceverse, your portal to cosmic adventures. New stars, 44 of them, hidden in a galaxy 7 billion light-years distant, have been discovered by NASA's James Webb Telescope. However, how were they created? These stars are ancient red supergiants, which means they are blazing at a far hotter temperature than our Sun. How were such blazing behemoths formed? Is something outside of themselves influencing them? The miracle of gravitational lensing has enlarged this faraway galaxy, revealing mysteries that have persisted since the beginning of time. What further secrets may be concealed amid its luminous tangles? With each new piece of information, we get closer to solving the biggest mystery in the cosmos. Gravitational lensing, one of the most impressive cosmic tricks, allowed for this huge breakthrough in space science. Picture yourself peering into the past via a galaxy-sized telescope. In a nutshell, that is what transpired here. What they observe beyond that distorted light curtain, however, will alter our entire understanding of the cosmos. Envision a huge cluster of galaxies blocking our view of the target galaxy. The gravitational pull of this cluster distorts the light from the galaxy in the background, causing it to form distorted shapes like arcs and loops. Even with a powerful telescope like Webb, it would be difficult to see individual stars billions of light-years away without this cosmic magnifier. But the gravitational lensing allowed the telescope to focus on an area called the Dragon Arc. The name of this place comes from the fact that the warped light here makes a dragon's body appear to be curving through space. Things are about to get interesting from here on out. The majority of those 44 stars are classified as red supergiants by astronomers. Imagine these celestial bodies as enormous, long-gone stars whose blazing brightness makes our sun appear like a candlestick. When these red supergiants explode as supernovae, they release heavy materials into space, making them an important component of the universe's overall structure. Carbon and oxygen, the fundamental elements for all forms of life, could not have formed in the absence of stars like these. Few individual stars had been detected in faraway galaxies prior to Webb's major discovery. Only approximately 7 of these stars were detected by Hubble, the de facto leader for decades. Those figures are completely out of the question in light of this latest finding. The formation of stars and galaxies during the early universe's cosmic cradle is fundamentally altered by this discovery, and it's not only about setting new records. Aside from the obvious discovery of some very old stars, why is this relevant? Concerning dark matter, that is all. That enigmatic, unseen substance that constitutes the vast majority of the cosmos. We can't directly observe dark matter since it doesn't emit or reflect light, but its gravity affects light. By analyzing the Dragon Arc's distortion caused by the Abell 370 galaxy cluster, researchers can map dark matter's presence. Abell 370 acts as a cosmic lens, magnifying distant stars with its massive dark matter halo and smaller microlens from individual stars. This allows astronomers to study faraway red supergiants, key to understanding early galaxy and star formation. Webb's discovery is like looking back in time, offering a glimpse into the universe's infancy. Each of the 44 newly found stars reveals clues about cosmic evolution. With its extraordinary sensitivity, Webb may uncover even more hidden celestial treasures. Discussions have begun about using the telescope for further deep space star hunts. Expanding the sample will refine our understanding of the early universe, from its shaping forces to the life cycles of ancient stars. What's even more astonishing? The light reaching Webb today began its journey billions of years ago, before Earth was even habitable. Thanks to cutting-edge space technology, we can now study stars that predate our solar system. The Dragon Arc stars aren't just distant points of light, they are cosmic time capsules, burning through their fuel at incredible rates, far larger and brighter than our Sun. With a lifespan of only a few million years at most, these stars are destined for a spectacular explosion. In spite of their brief existence, they dispersed heavy metals across the galaxy and altered their surroundings. Another proof of how impressive Webb's infrared capabilities are is this finding. If there were clouds of dust or gas, infrared light would still be able to reach its target. That is a major consideration when attempting to examine stars in faraway galaxies contaminated with dust. Because Webb is able to see through that fog, details that were previously invisible are now readily apparent. Discoveries like this give astronomers a leg up in their quest to understand the early cosmos. Searching for patterns in the data that may provide light on the formation and evolution of stars in the distant past is the next priority. They will be careful to spot any stars that don't seem to be red supergiants. These strange balls may provide light on the early universe's star population. The possible effect on our knowledge of dark matter should not be overlooked either. If dark matter didn't exert its additional gravitational attraction on light, gravitational lensing wouldn't actually work. In order to better understand the distribution and hiding places of dark matter, scientists are analyzing the distorted and magnified light from these stars. The nature of dark matter is still a great scientific mystery, therefore this is very significant. Put simply, this finding is a huge victory for space exploration. That the James Webb Space Telescope is performing as expected and more is demonstrated by this. Discovery of faraway stars is only part of the story. A new window into the cosmos is being unveiled here as well. That Webb is only at the beginning is evident from the prospect of future discoveries of this kind. Despite its fantastical sound, NASA's most recent discovery is based on hard science. The strong optics of the telescope, along with some cosmic serendipity, have allowed us to see stars that have been glowing for billions of years. This finding serves as a sobering reminder that there is a great deal more to understand about the large and mysterious cosmos. Astronomers aren't just counting stars, they're studying their conditions. Understanding the red supergiants in the Dragon Arc could reveal how they evolve and explode. When a red supergiant goes supernova, it doesn't just die, it creates new elements that may form stars, planets, or even life. With 44 newly discovered stars, scientists have a rare chance to study stellar evolution up close. This discovery is part of a larger effort to trace the universe's origins. The Dragon Arc stars are at different life stages, some shining brightly, others nearing their explosive end, helping astronomers piece together the story of stellar evolution. Such breakthroughs wouldn't be possible without global collaboration. The James Webb Space Telescope is a testament to years of teamwork by scientists and engineers worldwide. When will this cutting-edge tech show us what's next? Come with me into the age of space travel. December 2021, a spacecraft lifts off from Earth, transporting the James Webb Space Telescope and incredible instruments. Once all of its intricate components have been fine-tuned and aligned, this revolutionary observatory is finally prepared to take flight. Its official launch date is July 11, 2022, and the following day its first image is revealed. All our previous assumptions about space have been utterly disproven by this technological wonder in its short 2-year existence. Strange solar system objects and faraway galaxies that appear to be rewriting the rules of the cosmos have both been discovered by it. The first pictures taken by the state-of-the-art device are now up for discussion. They didn't merely display visually appealing content, oh no. Scientists were presented with an unexpected puzzle by them. Suddenly, you see a bright red dot that doesn't seem quite right while gazing at a breathtaking photo of faraway galaxies. Bright? Of course. Is it red? Fine. But in a vibrant crimson hue? I find that peculiar. The expansion of the universe causes a phenomenon known as redshift, which is responsible for the color red. Extending its wavelength and moving closer to the red end of the spectrum, light travels from distant locations. How far away something is and how ancient it is can be determined using this method. Is brightness the problem? The number of stars in a galaxy may typically be determined from that. This little red dot didn't match the typical plot because it was extremely far and extremely brilliant. Out of the blue came some staggering statistics. A galaxy 100 billion stars strong and 13 billion light-years distant. A galaxy the size of our Milky Way is about comparable to that. Scientists were under the impression that a galaxy of such size shouldn't have formed that rapidly following the Big Bang. More of these implausible galaxies appeared, further perplexing matters. Scientists began referring to them as universe breakers since they disrupted the theoretical blueprint for galaxy formation. Even though galaxies should take a couple of billion years to grow that massive, these galaxies seem to have formed just a few 100 million years after the universe began, contrary to current theory. Some thoughts have occurred to me. Theoretically, these objects could be quasars rather than enormous galaxies. In its most basic form, a quasar is the galactic core's supermassive black hole, which emits light bright enough to illuminate other galaxies. Bursty star formation is an alternative theory that proposes the rapid rather than gradual development of a large number of stars. This has the potential to greatly exaggerate the apparent brightness of a galaxy. While that may account for their luminosity, it still leaves the issue of their enormous size unresolved. Alright, let's move on to the topic of black holes. Those deadly cosmic vacuums that swoop down and devour anything in their path. Astonishingly, the oldest black hole yet discovered, Sears 1019, was discovered in April 2023 by the sophisticated Space Observatory. This massive object, which created some 570 MYR after the Big Bang, is around 10 MR lighter than the Sun. It's much older than any black hole should be, but it's smaller than other supermassive black holes. Shortly thereafter, GNZ11, a black hole located in the galactic core that dates back 400 million years after the Big Bang, was also discovered. By conventional wisdom, these black holes should not have had the time to enlarge to such a magnitude. Unexpected revelations lie ahead as the cosmos progresses. So, what's in store? Then how did they come to be so quickly? These black holes may not have originated from dying stars collapsing, but rather from the direct collapse of enormous gas clouds, according to one theory. A third theory proposes hypothetical stars devoid of heavy elements and composed solely of hydrogen and helium, known as population 3 stars. Black holes formed when these stars burst into massive explosions would expand swiftly after their deaths from intense burning. Prehistoric black holes, or extremely small black holes that may have originated immediately following the Big Bang, are the subjects of another outlandish notion. Everything our current understanding of the early cosmos is based on it, if it's true. If you thought things couldn't get any stranger, then consider the Orion Nebula, where an observatory in space discovered 40 pairs of objects that are being referred to as jumbos. Nobody saw these coming. These celestial bodies, which drift in pairs, are approximately Jupiter's size. However, neither planets nor stars do they exactly fit the bill. They fall somewhere in the middle. Their bizarreness is compounded by the fact that they are not orbiting anything, but rather simply gliding through space. The kicker is that according to gas physics, an object as massive as Jupiter cannot spontaneously form in a remote area. Jupiter and the other planets in our solar system do not originate independently. Still, see the bizarre jumbo couples drifting aimlessly. They may have been expelled from a solar system, but that still doesn't explain how they were paired up. It seems quite unlikely that two people could be removed from the same system without separating. Nonetheless, in just one area of space, this sophisticated space telescope detected 40 such couples. Using its advanced technology, this observatory is discovering surprises both far away and in our own backyard, in addition to distant galaxies and strange space objects. It unintentionally found a small asteroid, measuring 100 to 200 meters in length, while directing some of its instruments towards the asteroid belt that lies between Jupiter and Mars. This observatory had never before witnessed an asteroid of this size. Normally, it would be quite difficult to spot something so little, but it accidentally did it while doing standard testing. That is, why is it important? As far back as our solar system can be traced, the asteroid belt may be found. It preserves artifacts from the beginning, when all was yet in its embryonic stage. Small asteroids like this one could provide light on the origins of our solar system if they are located and studied. Thanks to the Space Observatory's unintentional find, we may be able to fill in some of the gaps in our knowledge of the solar system's past by discovering even more of these small space pebbles. While we're on the subject of planets, the Kepler Space Telescope found an intriguing exoplanet in 2015 K2-18b. Its orbit takes place around a red dwarf star in Leo, which is located approximately 124 light-years away. A unique feature of K2-18b is its location within the so-called habitable zone, an area where liquid water might potentially exist under certain conditions. Scientists found water vapor on an exoplanet in 2019, marking the first instance of water on an exoplanet in a habitable zone. Afterwards, in 2023, the Space Telescope re-examined K2-18b and uncovered a new chemical, dimethyl sulfide, or DMS, that can only be generated by earthly living organisms such as plankton. Obviously, this doesn't prove that K2-18b is habitable, but it is a promising hint. Unsurprisingly, there is a catch. No one knows for sure whether the planet has a solid surface, and there doesn't seem to be much water vapor in the atmosphere either. The question of whether K2-18b is actually habitable remains unanswered at this time, but it is certainly an object to monitor. The telescope is planning to do some serious stargazing in 2025 in an effort to resolve some major cosmic mysteries. Between the middle of 2024 and the middle of 2025, this telescope will be participating in Cycle 3, during which it will observe the sky for more than 5,500 hours. We are about to expand our understanding of space thanks to 253 separate monitoring missions. Identifying potential moons of extraterrestrial worlds will occupy a significant portion of its work. About 1,115 light-years away from Earth, there is a gas giant known as Kepler-1670 that scientists are keeping an eye on. They are hoping to find moons in its orbit using the telescope's state-of-the-art slitless spectrograph and near-infrared imager. If their findings pan out, it would be an unprecedented confirmation of the presence of an exomoon, quite bizarre when you put it that way. Another objective is to observe supermassive black holes up close. These monstrosities reside in the galactic cores, and the purpose of the telescope is to study quasars, those luminous remnants from the early stages of the cosmos. Astronomers study these in the hopes of understanding the formation and effects of these massive black holes on the galaxies in their vicinity. It's similar to attempting to deduce the expansion of cities by analyzing their busiest intersections. Not only that though, looking at old galaxies from about 500 million years after the Big Bang is what the telescope is designed to do. Peer into the far past of the universe. During this time, reionization, the process of removing an electron from a hydrogen atom, was taking place, and the temperature was rising. Understanding how it occurred is crucial for reconstructing the tale of the universe's beginning. Titan, the largest moon of Saturn, is the target closer to home for the telescope. Titan is like a science fiction planet with living, breathing lakes of methane and a thick, hazy atmosphere. Even if the atmosphere is completely different from our own, the telescope will still be able to map out what's happening under that hazy sky and determine whether life is possible there. At the same time, the directors of the Space Telescope Science Institute aren't letting up. They're already making preparations for Cycle 4, the following iteration, which begins in the middle of 2025. Massive 800,500 observation hours are in the works. Anyone involved in the space industry will be swamped with proposals due on October 16, 2024. Wonder whether the strange lakes of Titan could be home to alien life. Can we expect discoveries that reshape science to be made in Cycle 4? And if you love unraveling the mysteries of the universe as much as we do, make sure to hit that like button, subscribe to Spaceverse, and turn on notifications so you never miss our next deep dive into the great unknown.